On board, Richard McPherson is going to be joining us. Richard is the CEO of Idaho Energy, which is a subsidiary of Micronuclear LLC. He's been involved in the nuclear energy industry since 1964 and as a former U.S. representative to the International Atomic Energy Agency and one of their big studies. So we're going to talk with him about micronuclear and some of the other issues that we could be dealing with, wind, solar, and more. And it should be a good partner discussion for what we just finished up here this morning. All right, let's jump into this here, and we'll get things started. We're going to jump over here and start talking with our guest joining us this morning, Richard McPherson, who is coming on the program to talk about all kinds of energy policies, including wind, solar, fusion, and more. Good morning, sir. How are you?
Good morning. How are you? And I didn't know who you were until I've just watched you for the last hour.
Oh, okay. Well, good.
And can we have a few more common sense folks like you around?
Well, I appreciate that. I mean, I'm not the sharpest tool in the shed, but at least I can figure out which end is the stick is pointy. I mean, this is ridiculous at this point. We got stuff going on. I'm excited to talk to you about a lot of these concepts because I think the one thing that we keep missing in this whole discussion, and obviously I think is the discussion of alternatives like nuclear, micronuclear, and some of the other things. I mean, it amazes me that we're talking about renewable energy, and the one thing that never gets discussed in the renewable energy debate is hydro. Hydro is, overall, it is the cheapest, most efficient, most affordable, cleanest energy generation by far, with nuclear coming in second. But you put in a dam, I mean, the Hoover Dam has been there for 100 years, still generating power at 3 cents a kilowatt hour or something? I mean, it's insane. And yet, that's not part of the discussion. We got to build solar panels and things and all that, and nobody ever talks about it's just, it incenses me, I guess, at this point, Richard, that's what's going on. But it's it's amazing. This is the world we live in with intelligent creatures like us, as Jeannie just said, intelligent creatures basically being bought off and pushing this clearly insane energy policy agendas for billions of dollars that most people don't even know about.
I agree with you about the hydro. And the unfortunate thing about hydro is we focused on large hydro during a period of time during World War II when we needed a bunch more electricity. And one of the things that's been overlooked over the years is micro or mini hydro. The United States has put some in, not nearly enough. About 10 years or so ago, I talked with a fellow back in Pennsylvania. They'd had a micro hydro plant working there that was like, 400 or 500 kilowatts, but it had been working since 1909.
Exactly. I mean, it doesn't have to be the size of the Hoover Dam. It doesn't have to be Niagara Falls. It could be a small creek or stream that's running. I mean, I've seen plans for home-based micro hydro. I mean, there's all kinds of things that can be done with that. All right. I don't want to get too far into this, Richard, because we're just coming up out of the commercial break and we're going to start the hour. And it's going to be all you all the time for the next hour or so. I'm really interested to pick your brain and talk about a lot of these things. And so let's get ready for a free roaming conversation on this. Okay.
I'm ready.
Okay. We'll be right back to you. Don't go anywhere. Richard McPherson, our guest. We're going to continue here in just a second. Today, our discussion has been, in part, a continuation of yesterday's discussion about energy policy. And, of course, the ridiculousness of trying to ban one of the cleanest burning hydrocarbons out there, natural gas, and everything else. And that kind of morphed into a discussion of energy across the country. We've got news about rolling blackouts. We've got all this idea how everything should be pushed to electrical, but we have no infrastructure to make it happen. And now they want more EV cars, and they want everything to be pushed on that. Of course, the one thing that they're really not talking about is the alternatives to renewables which of course include hydro and micronuclear. And so to discuss this with us and to come on board and talk with us is Richard McPherson. He's the CEO of Idaho Energy, which is a subsidiary of Micronuclear. He's been involved in the nuclear industry since 1964, and he was the U.S. representative to the IAEA, the International Atomic Energy Agency, on a big study called Nuclear Fuel Cycle Facilities. And he is focusing on manufacturing and deploying nuclear batteries, which we here in Alaska are pretty familiar with because that's been a discussion and a talking point we've had for, like I said, maybe the last 15 years. I remember we were talking about it in Fairbanks for the Toshiba nuclear battery maybe 15 years ago, and how that could solve a lot of our rural energy, super rural, like urban bush and bush community and village problems. Joining us right now, Richard McPherson comes on the program to discuss, and we welcome him to the show. Good morning, sir. Thank you for coming on board. We appreciate it.
Good morning. It's my pleasure. I've been looking forward to talking to you and talking about Alaska.
Well, I appreciate that. Thank you. Now, we just got done talking about this idea, which seems to be getting a lot of press, which of course is this idea of eliminating hydrocarbons in any way, shape, or form. Not just fuel oil, not just heating oil, but now natural gas and everything else. One of the cleanest burning hydrocarbons. And this push to electrify everything. Everything in the home should be electrified. Your heating, your gas, your cooking, and all this other kind of stuff. But there's some potential problems that we've talked about. Namely, we don't have a power grid that is capable of generating enough power to do all those things. We're already talking about rolling blackouts in places like California and things like that. They want everybody to get an EV, an electrical vehicle, regardless of the fact that in Alaska, they don't work nearly as well as they do in other places, right? And of course, we don't have charging stations, and again, the power thing. But this whole thing is a push to this renewable energy, which is a weather-dependent system, and yet they leave out things like hydro, be it macro or micro, and they leave out what I think is probably the future of the way things are going, which is nuclear. Give us your thoughts on what we've been talking about.
Well, you're right about hydro, and I've been trying to get people to do more hydro and also more geothermal over the years. Once we came up with geothermal, the problem was originally that they were using up all the water,
Right.
or they were spilling it out over the countryside. Once they came up with a system where they reclaimed the water and pumped the brine and everything back down in the ground, they had a pretty good system. And the best system that was made back in the 70s was down at the China Lake Naval Ordnance Test Station, and I got to visit with a guy that put it in there, and it sort of led the way into much better systems we have. But we don't have enough of them. We're not taking advantage of geothermal the way we can around the world. Also, we're not taking advantage of hydro. Last summer, I had somebody approach me about the Congo River, which is about the fifth or sixth time in my life that somebody has. And I said, it's very simple with the Congo River, any of those rivers. The people live in small villages along the 2,900 miles. Micro or mini hydro is available, and that's what you should be pursuing. You don't need to put in a large electrical grid where it's almost impossible to put it in. And electrical grids are very vulnerable to all kinds of things that will upset it. So, but going into this, I would like you to know a couple of things. First of all, I'm an all energy person. I'm one of the few people that we know that is an all energy person. I've worked in every energy type of energy conversion there is. And talking about energy conversion, people like to use the term renewable energy.
Right.
And it's not renewable. That's the first thing that people make a mistake. They bought into the fact that it's renewable. Well, because they're thinking about the wind and they're thinking about the solar, and but the fact of the matter is you have to have something that converts wind and solar into usable electricity. There is where the renewable goes away.
Right.
because the capabilities to turn them into something useful causes other problems, such as for both wind and solar, when you cover the ground over with them, you're creating ecological damage underneath them of a 4 billion years of evolution. It's bad enough that we take in some areas and indiscriminately cover them over, and we do the same thing. We don't need to be doing that with wind and solar. Also, wind and solar take too much of our natural resources out of the ground, which are finite. We can't afford it. We
You're, ta-
also have no way.
you're talking about the construction of the actual mechanisms for converting that energy, the silicon,
That's
the
right.
solar
That's
panels,
right.
the generation, the wind, all those takes very specific resources of which, again, there is a finite amount. And the cost and the lifespan of those things, I saw a study one time that said a solar panel doesn't ever even pay back its production costs is in terms of energy because of how much energy it takes to produce that panel.
When you look at the total life cycle costs of a solar panel or wind, they do not. You're right. But the thing is that people have bought into this. Here's why they've bought into it. There was a law passed in 1974. There was a knee-jerk reaction to the Arab oil embargo in 1973 by Congress that allowed the Congress to take money away from taxpayers and give it to developers of wind and solar. It didn't take long for people in Congress to find out that they could give it to developers, and the developers would kick back money to them to get them reelected. And the same thing is now happening with batteries.
Right, right. No, I mean, that's the thing. Batteries, these big lithium things, the Tesla wall thing, all those things are great, except for one, they are extremely resource hungry. And two, they require power to be generated somewhere else in some other form to then feed them. Which is just, I mean, again, it's like, oh, we'll have an all electric thing. Yeah, but where is the electricity going to come from? You may be not hurting the environment or not expelling hydrocarbons in one area, but you've just upped the production of hydrocarbons in another area. So it's insane.
They leave that out of the equation. They just talk about charging. And so you brought up California earlier as a good example. California's, they're nuts in a lot of ways, but the electricity use is the worst of all. They have to import perhaps 15,000 megawatts a day when the wind and solar is not operating. They also use wind and solar. They put so much into wind and solar in California that they're actually not able to use it all during some times of the day when but they have a lot of sun and a lot of solar. So that's all taxpayers. So that's taxpayers' money. So the politicians and the governor of California, they don't care. But taxpayers should care, but taxpayers are being sold a bill of goods.
Right.
You talk about Alaska, okay, and you talk about getting rid of natural gas. Well, natural gas provides about 50% of the home heating or residence or building heating in the state of Alaska. You got the pipelines in place. You've got the natural gas available. It's stupid to get rid of natural gas. And when you talk about everybody trying to force us into electricity, electricity in Alaska is about 14% thereabouts that used for heating. That's not very much. So to get rid of the natural gas, you're going to have to put in a bunch of transmission and distribution lines, which are very vulnerable. And in my opinion, because I started my first 20 years in the Navy, and I've been involved in energy, national security, and economics ever since then. Alaska is the number one state at risk from China, North Korea, and Russia. And to do anything to upset instead of enhance the capabilities in Alaska is stupid. And Alaska does need nuclear. I need to take you back and tell you something else. When I was at the International Atomic Energy Agency, I maintained an office in California, and I was visiting back there around 1991. My secretary says, "The governor of Alaska is on the phone for you." I said, "Are you sure?" Sandy said, "He says he's a governor." So I said, "I'll take it," because no governor had ever called me. So it's Wally Hickel. And he said, "Can you be up here tomorrow morning at 8 o'clock in the morning for a meeting about energy at the Captain Cook Hotel?" And I said, "Yes." I didn't know he owned the Captain Cook Hotel. I also didn't know how I was going to get there. And Sandy found me a flight that was leaving in 40 minutes from San Diego. That was before trying to get through something today.
Right.
And I actually made the flight, went to Seattle, and went up to Anchorage. And I attended a meeting. And he had a simple request. He had found out about me from somebody in Washington, D.C. I forget who now. And he had a very simple request to us that were in the room. There was 6 other people from Alaska and myself and him. And he said, "I want to find a way to reduce the cost of energy for Alaskans." And he said that the oil pipeline has peaked and now it's falling off. We will see a day that there will not be enough oil in the pipeline for it to continue to flow. So your point earlier that in the show when you talked about the new field coming online, that's really good. And
Right.
there's lots of opportunities to do that in Alaska, and Alaska should be pursuing them. So he said, but he made a simple request. So for 2 years, I worked with him, both in and out of the state, and we looked at everything, including nuclear. And that's when Toshiba showed up one day with their 4S system, about 2003, somewhere in there. Well, I knew what Toshiba was trying to design, but they hadn't designed it yet. And the claims that they were making to the people in Galena and other places in Alaska were not true. But I didn't say anything. I just watched it because if they could actually develop that and make it work, it would be very helpful in Alaska. Fast forward to today, we do have that power plant for Alaska, and it's called the molten salt nuclear battery. And the molten salt nuclear battery is a product of a man that was at Capel with naval reactors. He went there in 1983, the year I retired. He designs nuclear reactors for the Navy, Dr. Paul Murata. And I got a call from him in early 2018. And he said, "I've developed a reactor that has no pumps and no valves. It's natural circulation." I was hooked. So I only intended on advising him a little bit along the way. But now what's happened is I found somebody that can manufacture it in Idaho, in Blackfoot, Idaho, called Premier Technologies Incorporated. And so I've accepted the position to take the responsibility to get them manufactured, tested, and deployed. And I've been to Alaska twice in the last few months. I went to I went to Allison Air Force Base just to listen to what they're proposing up there. And they're proposing, as the Deputy Assistant Secretary of the Air Force said, as a project or pilot plant to see if microreactors will work and provide electricity and steam by sometime around 2030. So I was nice enough not to tell her that we proved that point during the Manhattan Project, and we've proved that same point with every nuclear submarine that's been built since.
Right. Exactly.
So I just left that alone. Actually, I also didn't tell them at Eielson Air Force Base that I'd been there 30 years before. I'd been to all the military bases in Alaska. It was part of what I was doing with Governor Hickel. And my recommendation was they get off the sources they're at now from a national security standpoint and go to nuclear. They haven't done that. Eielson Air Force Base is dependent upon 15 rail cars a day arriving from Usabelli Mine during the middle of the winter when it's 50, 60 degrees below. And if those rail cars don't arrive, Eielson Air Force Base becomes a base that you've got 6,000 people working and living there, that you suddenly have to figure out how to save their lives from freezing to death.
Right.
Because they're totally dependent on coal. So I'm not very impressed with over the last 30 years, our Department of Defense hasn't done a better job at protecting our bases. Because as the commanding officer of Eielson Air Force Base said, we're the tip of the spear against China, North Korea, and Russia, because I've got 54 F-35s here. Well, the tip of the spear in one day can become no longer the tip of the spear, but a group of people that need to be rescuing from the lower 48. And the lower 48 is not capable of doing it in time.
Right. No, this is and this is something that I've been arguing about for a long time. Again, starting back in the early 2000s with the discussion of the nuclear battery. We're talking with Richard McPherson from Micronuclear, and we're going to continue this discussion here in just a moment. Coming up on the break, so we're going to continue this discussion and look at real world scenarios, look at what the solution is, talk specifically about their micro reactor and what it could mean, not just for Alaska, but for the rest of the country. The Michael Duke Show. Common sense, liberty-based, free thinking radio.
Streaming live every weekday morning on Facebook Live and MichaelDukesShow.com.
We're back in the commercial break right now with Richard McPherson. Richard, it astonishes me, like you said, 30 years, and they're going, oh, well, maybe we should test. It's been tested. I mean, I've never understood that whole idea. You've got nuclear aircraft carriers, destroyers, submarines that for years have been utilizing this small plant technology, small plant captive technology. And you could be running bases around the world. You could be running municipalities and cities and whole power grids with this. And, you haven't had a problem with these nuclear reactors on these ships. And those are like full reactors. These aren't like battery self-contained things, right? I mean, this is a whole thing. And now you've got a technology that's even better. And yet they're still acting like we're in the test phases of this thing.
Yeah, well, you got to, the governments are all the same. Whether it's a city government, a state government, or the federal government, there are it's made up of a bunch of individual organizations that I call stovepipe. They have their budgets, they have their jobs, and they're happy for the next year. In the case of the federal government is stovepiped with thousands of them, and they don't talk to each other. It's one of the reasons why we were attacked on 9/11, because you had 95 intelligence services within the government that didn't communicate with each other. We knew what was, some of them knew part of what was coming on 9/11, but they never put it together because they didn't communicate. Well, it's even worse when it comes to energy. We haven't had a cogent energy policy during my lifetime. The closest we came to it was when a former chief of naval operations by the name of Admiral James D. Watkins became Secretary of Energy under Ronald Reagan. He started getting his hands around the Department of Energy and started to make it worthwhile. Unfortunately, that was the same time I was representing the United States at the International Atomic Energy Agency. And by the way, our 4 years of study over there was because of Chernobyl. And we studied nuclear fuel cycle facilities, the environment, and public opinion. I'm the only American that's ever had the opportunity to do that for 4 years uninterrupted. So getting back to Alaska and getting back to the molten salt nuclear battery. Alaska has a bunch of military bases, and they should already have the molten salt nuclear battery. I can tell you that we notified the Department of Defense that it existed, but we weren't going to talk about it in 2019. And the Department of Defense hasn't taken advantage of it. Alaska, Hawaii, Guam, Wake Island, the Northern Marianas Islands, and the Republic of Palau are all at the greatest risk from China. We know what China is up to. We know what they'd like to do. They're cooperating with North Korea. They're cooperating with Russia. It's absolutely foolish that Alaska is not already protected, and they can be starting next year. Alaska is probably paying on average. Some are higher, some are a little bit lower, depending on whether it's summer or winter. But Alaska is paying around 20 cents per kilowatt hour for electricity. With a molten salt nuclear battery, and to give you an idea of just the design that was made just for military bases, it's a 10 megawatt design. It's 1.5 meters in diameter. It's 3 meters tall. Comes with a very small, so that is the size of a 10 megawatt molten salt nuclear battery, a microreactor. That's all it is. They're designed to be in an underground vault, or in the case of Alaska, up where You have the Tundra, it'll go into an above ground vault that'll be made similar to, it'll almost look like a ship's hull. But we can produce, depending on the transportation costs or what taxes that the government might impose on it, we can produce electricity and match that 20 cents per kilowatt hour or less, but it'll be EMP protected, electromagnetic
Right.
pulse protected,
Yeah.
and cyber protected electricity.
Hold on a second here, Richard. We're about to rejoin the radio, and I don't want to repeat ourselves too much here. Richard McPherson is our guest. The Michael Duke Show continues. Common sense, liberty-based, free-thinking radio. Let's do this thing.
The Michael Duke Show. Not your daddy. Wait, sorry. Not your daddy? Ooh, not your daddy's talk radio. Whew. I was scared for a second. Thought we were going down. Here's Michael Dukes and the show.
That's right. Not your daddy, nor your daddy's talk radio. It is the Michael Duke Show. Common sense, liberty-based, free-thinking radio. We do it every day right here. We're continuing our discussions now on energy with Richard McPherson. We're talking specifically about micronuclear. And, of course, this has been something that's been kicked around for a long time. And I was just saying to Richard, it amazes me that we have had nuclear-capable warships in the United States for decades, and yet we've never converted or moved that kind of idea onto military bases or for civilian applications. And those are like regular reactors. He's talking about something completely different, a self-contained unit with this molten salt reactor that is doesn't require all the bells and whistles that you'd see out there. And he was just telling us the difference here. Now, Richard just said that the average cost of power in the state of Alaska is about 20 cents per kilowatt hour. I can tell you that the people in Fairbanks would love to see 20 cents a kilowatt hour because I think they're paying upwards. I think when I left 9 years ago, I was paying something like 29 cents. In Glen Allen, I know they're paying like 37 cents per kilowatt hour. I mean, it's very, very expensive. When you got a family of four and your electric bill is $500 a month, it's a significant chunk. And if it could be done cheaper, more efficiently, and environmentally sound, more consistent, that makes sense. And these nuclear batteries that you're talking about are not, this is not a big 3 Mile Island, giant funnels in the sky and everything else. You were just telling us that a single 10 megawatt unit is about the size of a large propane tank and can be put just about anywhere, right? So give us the description of what this means.
So you're talking about a large propane tank. That's pretty good. So if you turn it up, on its end, that's about it. So originally, Dr. Paul Marotta, who came from Naval Reactors, who was designing reactors there for the Navy, he came up with this, and he made the original size for all our military bases in the country because he knows they need protecting and they're not protected. So it's for the 10 megawatt size, it's 1.5 meters in diameter and 3 meters tall. And then it just simply sends heat over to a small 10 megawatt generator. So we right now say you need about a 100 foot by 100 foot footprint on the ground to take into account the whole facility and the fence that goes around it. The reality is we've recently found, thanks to the Department of Energy, we've recently found a very small turbine generator. And it is the coolest turbine generator I've ever seen in my life. And I have seen a lot of them. And so we're going to be able to reduce that 100 by 100 feet to probably 50 by 50 feet. So the intention is to put these in an underground vault to protect them. And one of them will run for 10 years. And Paul calls it a battery because there's going to be no refueling in place. There's nothing going to be left there that's radioactive. We're simply going to replace it with another one at the end of 10 years. So it's like a battery. People fear that that we're going to somehow leave radionuclides all over the place for years. Not true. just like your car, you have from every 3 years or 4 years, you take your car in and they pull out a battery and put in a new one. Same thing will happen here.
Right.
It'll go back to a central facility, and we're already designing the systems for recycling the fuel in there. And a new one will be put in place. Now, there are some overland transportation issues in some parts of Alaska,
Sure.
so that might add to the cost a little bit. But in reality, the 20 cents per kilowatt hour that I quoted is a number that I've had for quite a while for Alaska. I don't think we were on the air when I was telling you that I got the call back around 1991 when I was visiting from the International Atomic Energy Agency to my office in California. And my secretary said, the governor of Alaska's on the phone.
Right. Yeah, we talked about that. And
And
you got a chance to meet and to help plan some
for
of this stuff.
for 2 years, I tried to help. We looked at everything for Alaska. And Wally Hickel his simple statement was this: I want to reduce the costs of energy for the people of Alaska. At the end of 2 years, I called him up and I said, Wally, I can't help you anymore because there's too many factions in the state that do not want to reduce the cost of energy for people in Alaska. So that's unfortunate because we could have done it then.
Yeah, no, I mean, the whole thing is unfortunate. And as you said, even back were discussions 20 years ago about the Toshiba battery, which was in concept. It wasn't even designed yet. You guys have now done it. I mean, we've had, what was it? It was not Clear, but out in Delta, Fort Greely had a regular nuclear reactor.
Yes.
And that has since been decommissioned. And I know that you, like you said, you've been up to Alaska recently. You've been visiting at Elmendorf and Eielson, and they're all looking at this because Alaska is at the point of the spear. And we need something that we can fall back on. And quite honestly, not just for military applications, but for civilian applications. I mean, as much as I enjoy the cost of the low cost of energy where I live now because it's all being generated by natural gas, if it could be done on a nuclear basis, we wouldn't have to worry about a lot of these things. And it would be, I'm assuming you can hook these up in series and go from 10 megawatts and scale it up to 100 megawatts, right? I mean, this is something that could be done in general.
Yeah, there's no limit to how many we could put. It's a very small footprint. You've got 149. Last number I've got is 149 incorporated cities in the state of Alaska. You've also got 30 Army National Guard facilities in Alaska. The military bases in the Army National Guard and Coast Guard, by the way, are the three most logical places or characterizations of places to put the molten salt nuclear battery first. And as a matter of fact, there is a city in Alaska that's talking to us right now about that. So, but the reason I say that is because the incorporated cities have something called first responders. From the state level, the greatest capacity for first responders is with the National Guard. So those are the ones that should be getting molten salt nuclear batteries first for continuity of services. Then to give you an idea of an average US city, one 10 megawatt molten salt nuclear battery can power 4,900 homes for 10 years. Now in Alaska, you're widely dispersed, so we may not use 10 megawatt reactors. We may use a 5 megawatt reactor or even less, or some range in there. But we know what the usage is in all the cities, and we would just match them for the cities.
Right.
And they would be underground in most cases in the southern part of the state. Up where the tundra is, they would simply be above ground in a vault that would look similar to the hull of a vessel. And we do that because as the tundra melts and moves around a little bit from times of the year, you want this facility to be able to move around with it.
Right.
So we've already taken that into account and designed it.
The biggest challenge here in the state of Alaska, of course, is our geography. We've got vast distances. And the problem, of course, is the cost of creating infrastructure from power generation to end users. We do have the rail belt, right? We stretched the inner tie between Anchorage and Fairbanks, 400 miles across the tundra of towers and wires and everything else. And, of course, the big challenge is in the villages and other places. How do we get there? How do we get to Galena? How do we get to Bethel? How do we get to, Barrow and various places around the state? This would alleviate a lot of those problems because you wouldn't have to build out the expensive generation transmission capacity between the various points.
And the transmission system in the United States has been really good to us over the years. But the transmission system now, whether it's in Alaska or any state or the entire North American, it's too vulnerable for many kinds of attacks. Or even as we're seeing in recent years, wildfires down in California, Oregon, and Washington, or freezing in Texas and other places. We started with a great North American blackout in 1965. We haven't learned from that. And we also know that China and Russia are in cyber-wise into our networks. They can shut us down anytime we want. So we need to be providing electricity closer to the end user. And that's one of the advantages of the molten salt nuclear battery.
As far as cost goes, you said that these batteries could make it comparable at the 20 cents a kilowatt hour or less. I'm assuming that there is a substantial investment up front in the cost of the molten salt battery. What are we talking about cost-wise for power generation? Give us an idea, ballpark it here, under what these things would cost on an ongoing basis. I mean, basically on a 10-year cycle. What would it take to do something like that?
Well, this is going to surprise you. We are actually setting up and working with some people setting up another company. It's a leasing company. We're not going to sell these. We're going to lease them.
Okay.
So whatever you're paying cents per kilowatt hour, you can just keep paying it. More than likely, so we'll do a contract probably for a lease that will be fixed for 10 years. There will probably be a CPI adjustment because of what the government might do to make changes in what the cost would be. But we're going to lease them, and we're going to lease them on a cents per kilowatt hour basis. So if the city of Anchorage, for instance, is paying 30 cents per kilowatt hour now, they probably have to pay something less for 10 years. The important thing about that is we will match it with a 10-year lease. And friends of mine who work in the utilities and have to deal with tariffs, where they go to the state utility commissions every year, they tell me that we might see in the United States, we might see the cost of electricity triple in the next 10 years. In the case of the molten salt nuclear battery, it would be fixed for 10 years, with the exception of probably a CPI adjustment.
So overall cheaper, more affordable, not dependent on hydrocarbons or renewables or anything else. Although you see this as part of the overall puzzle. This is not a standalone. This would be in conjunction with things like hydro, geothermal, tidal, wind, solar. All of those things could work together to create a more sound grid.
Yeah, whatever you have. And of course, when you get to wind and solar, what you have is intermittent and unreliable. So it makes for an unstable grid. People know that. It's a problem all over the place. The only reason we have wind and solar and batteries now is because of taxpayers, politicians taking money away from taxpayers and giving it to developers. There's one other thing that.
Well, before you get into the one other thing here, Richard, let me go back to break here because we're going to take our final break of the hour, and then we'll finish up with Richard McPherson from Micronuclear LLC, and we're going to talk with him a little bit more about how this could work and what kind of time frame and reality we're actually looking at. The Michael Duke Show, Common Sense Radio.
We're broadcasting live through a series of tubes.
Allowing all of these entities to provide streaming stuff going on the internet.
Well, it's kind of hard to explain. Sorry. Streaming live every weekday morning on Facebook Live and MichaelDukesShow.com.
Okay, in the break here with Richard McPherson. I've seen some questions in the chat room, Richard. Let me go back here and see what some of the folks are saying about this, or some questions from the chat room here. I want a micronuclear reactor for my house. Well, if your house could use a 10 kW or 10 megawatt, I don't think, even if they could scale it down, I don't know, maybe you could have a neighborhood reactor that could serve a neighborhood. Patrick asks, correct me if I'm wrong, didn't Clear have a nuclear power plant? It was Greeley, I think is what you're thinking about. I don't believe Clear did. I know Greeley had one.
It was Greeley.
Yeah, Greeley. Is he aware of other countries that are already implementing this technology? Asked Deshana. Is any other country already implementing this type of battery? I mean, the microsalt is your guys' baby, but is similar fields of thought being used in other countries right now?
The easy answer is yes, but here's why. We only disclosed that we had this in April at a presentation I made down in Florida. There was an annual meeting of an outfit called PACE, about 200 business owners. They have over 1 million employees around the country. And their theme this year was Saving America. And I was asked to come down and give a presentation about the molten salt nuclear battery and Saving America, which I did. So it came as a surprise to them, and it came as a surprise to a lot of people. Then we put out some press releases, and we have created a 10-minute video, which is on our website. So we've already been approached by somebody in Mexico, somebody in Africa, and we've been approached, and we're in serious conversations with people in the UK. And now, just 2 nights ago, I got an email from somebody in Sydney, Australia. So the word is already getting out. One of the one that's in the UK, they're very interested in powering mines. They own some mines in various countries around the world, because this makes it ideal for a mine site, because now you don't have to truck in all that diesel fuel.
Right. Are there any other downsides to this other than the transportation aspect you were talking about? I mean, that's kind of the tricky part, trying to get it transported to where it needs to be. Once it's in place, it's ultimately safe. I imagine the most delicate part is moving it across open ground somewhere. Any other downsides?
You know, I get asked this question all the time, but keep in mind that I've been in this business since 1963. At the International Atomic Energy Agency, I got to see every design there is, and I've been to quite a few of the facilities around the world. We don't have any downside that we're aware of. And we've got the smartest group of people working on this that's ever been assembled, working on nuclear power today. So there is no downsides. The question of waste is going to come up. Every energy conversion system has waste, as we do. But because we're going to recycle most of the fuel, we'll recycle over 90% of it and put it in other molten salt nuclear batteries. We're going to have some small amount of it left over as actinides. We already know how we're going to store them. And we also see technology changing to where some of the actinides will be used. So we don't have the problem that light water reactors have. Light water reactors being pressurized water reactors and boiling water reactors, of which about 66% of the current American fleet of commercial reactors is pressurized water reactors.
This is interesting. As far as conversion, actually, I want to get into that question once we get back to the radio. So because I don't want to repeat ourselves. Timothy makes the point: part of the cost of what we're dealing with is power companies have no competition. Is this something that power companies could pick up themselves instead of having it be a municipality or a government org or anything like that? could private power companies or cooperatives, as we have in the state, could they decide we're going to shut down our fuel oil burners, we're going to shut down our natural gas generation, and we could just literally park this here and plug it into the equipment that we have now?
Are we on the air?
Not yet. We're about a minute and a half out.
Okay. We've taken this into account because the utilities have to come into the modern world. And we're going to teach them how to come in the modern world. They're in the energy business. They want to stay in the energy business. Just like oil companies are really in the energy business, they want to stay there. And we've already been approached by one of the oil companies. So the oil companies do a better job at knowing to stay in the business than utilities do. But utilities are going to have to come in the modern world, and we'll help them do that.
All right, the ding means we're about to return to radio, so let's get things going on. Richard McPherson is our guest. Please like and share this show. Like and follow the show page. Let's get more people involved in this conversation and get educated on it. Richard McPherson continues with us here. It is the Michael Duke Show. Common sense, liberty-based, free-thinking radio. Like and share, like and share. Here we go. Okay, continuing and finalizing our discussion here with Richard McPherson, nuclear energy expert, also with Micronuclear LLC. You can find out information about this and watch a 10-minute video that they put together on their website at micronucleartech.com. They've got a whole video describing the molten salt nuclear battery, what it can do, and everything else. I'm interested to find out more. Let's talk about conversion here, Richard. This is something that could be plugged into existing generation systems, right? This does not require a whole build out on something new or anything else. This could be, I mean, if you've got utilities or co-ops or it doesn't have to be just military or government, but if you've got private co-ops, this could be something they could explore and would require very little conversion, right? Because all you're doing is removing the generation component of it, and you're plugging it into the steam and the turbines and everything else. It's already there. This would require a pretty low amount of conversion in that regard, right?
Yes, the utilities, they're in the energy business and they want to stay in the energy business. To be fair to the utilities, they have been hampered by changes in public policy for decades. And what I've seen during my lifetime is CEOs and presidents of utilities came from the power generation side and knew how it worked, into having to have lawyers and bankers and accountants be the senior people in utilities because they've got to deal with the regulations, changing regulations all the time, whether they be from the federal government or from the state. So they've been ruined as good companies simply by changes in public policy. We've made allowances for them with a molten salt nuclear battery to teach them how to convert from where they are today into a new modern utility that does not depend on the grid, that puts power directly to the end users.
The question is, of course, as I said, we've been talking about this in the state. You said 1991 was when Hickel contacted you. We've been talking about it in the public more. It came into the public eye in the early 2000s with, again, the discussion on the Toshiba battery and everything. But we've been talking about this for 30 years in the state. And yet we seem to be no closer than ever before. And, of course, energy, cheap, affordable, reliable energy is the cornerstone of any progressing civilization. In fact, it's what makes the whole thing turn. It's what allows us to innovate and gives us time to think and invent and create art, music, and science and everything else. And so it is one of the most important things. How far away is this more pie in the sky? Because, again, a lot of us are, like I said, been watching this for years and thinking, oh, it'll be next year. Oh, it'll be, to 5 years. Oh, it'll be. But it sounds like this is that we're ready, that maybe now is the time and we're ready. What do you think?
Yeah, we're in the final design. We've been doing computer modeling and testing all along the way. So we have done the testing that we can do without uranium to match it against the computer modeling now for 5 years. And all of our testing has been done with scaled models that are exactly scaled to what the molten salt nuclear battery would be. And in all cases, it matched the computer programming or computer modeling. To give you an idea of what computer modeling that we talk about is, you may be familiar with the Boeing 777 Dreamliner.
Right.
And that was an airplane that was designed and built and flown on a computer. Well, that's where we are today. We don't have to come up with prototypes anymore. We can do all of our design work and all of our testing for safety analysis and everything on computers, and we've done that. We're getting ready to enter into an agreement with a national laboratory. It appears as though they want one of these so they can get the data from it. Once we do that, we will then be able to go into production for places like military bases, Coast Guard bases, Native Indian corporations, National Guard units, because what we're going to do, instead of going through the Nuclear Regulatory Commission for cities and commercial purposes first, we're going to get one of these operating on a federal reservation so we have real data. So we're not like everybody else that goes to the Nuclear Regulatory Commission that has a bunch of nuclear people running it and be at the mercy of them for years. We're working. There's a lot of people working with us. I'm in Washington, D.C. right now, and I suddenly became a big hit back here, and people have been asking me to come to visit because our approach is completely different. But you got to understand, Michael, we're all old. We've been in this business for a long time. I've been in it since '64. I've got another guy that's went to the same nuclear power class as I did. He was in Alaska with me recently. And we have the single best team that's in the design and overall nuclear business that's ever been put together in the world.
So I was just going to say, you're not a spring chicken. So does this get done? Does this get done in your lifetime? Does it get done in my lifetime? I mean, that's my question.
If I get my way, we will be actually manufacturing them for lease and installations next year.
Next year. So, I mean, really, technically, in 5 to 10 years, these could be proliferating around the country, not just in military bases, but potentially on the commercial side as well.
My goal is in 10 years is to have 27,000 of them working in the United States.
27,000. I mean, this is, I think this is the ultimate goal. This is where we need to go. And if you've got a 95% recapture, 95% recapture on fuels and everything else, and the waste issue is solved. And again, this is much more, it's a safer unit. It's all self-contained. I could see as how this could be the future. We're coming down to the last couple of minutes here, Richard. So I wanted to give you the floor and just let you summate and sum up and wrap up and tell us how we can help or find out more. What do we need to do?
Well, we can stay in touch and you can find out more. You can go to our website. Now that we've gone public with what we're doing and who we are, we're going to be updating our website all the time. We're not going to be quiet about what we're doing. We're not going to be secretive of what we're doing. Unlike most of the other manufacturers today, we have our manufacturing side is all in place. The manufacturer that we have an agreement with, there's something called, there's a nuclear quality assurance standard that comes out of the American Society of Mechanical Engineers. And the company that we've chosen to partner with and certify them is in Blackfoot, Idaho, called Premier Technology, Inc. They've already done over 1,000 jobs, mostly for the government, some for private industry, under that NQA1, that nuclear quality assurance standard. And they're the ones that we're going to have build ours. And in all respects, we're ready to go, with the exception we've got to get this first test out of the way. But we have somebody that wants the data from it. So they're starting to drive our train now, which only helps us get it into production sooner to be able to get it on military bases, Coast Guard bases, Native Indian corporations, et cetera, where they can all take them now.
The future is now. The future is now. I hope, anyway. Richard McPherson, micronucleartech.com is their website. You can go check it out. I think Alaska would be the perfect commercial test bed for this kind of thing, strictly based on, again, on geography, transmission requirements, and everything else. Richard, definitely keep me in the loop here. Let me know if anything comes out. We'll have you back on the program. Hold the line.
Thank you for what you do.
I appreciate it. Hold the line for just 1 second. Folks, we're out of time for today. Tomorrow is Firearms Friday. That's right. We're going to talk about the Second Amendment and more tomorrow. It's all coming up. You're going to have a great day today, I guarantee it. Be kind. Love one another. Live well. The Michael Duke Show. So this is kind of the show after the show, Richard. I want to give you anything that we didn't hit, any points that we didn't make, anything that I missed, or any final thoughts that you may have. I wanted to give you the wrap up.
I'd like to bring up fusion for a moment.
Sure.
There's a lot of misinformation about fusion, and there's a bunch of money being put in fusion, which is being squandered. Fusion is a material science problem. And we need fission reactors to be able to generate the wealth in this country to do more research in material science. During the Reagan administration, when we had space wars or spa wars, they needed a material that would withstand 4,000 degrees continuously. We came up with that. That was 30 years ago. We haven't come up with a material that can withstand over 4,000 degrees since then. It's a material science problem. It's not just a material science problem for nuclear energy, but it's everything we do. Everything that Americans, not just Americans, but the world. I'll leave you with this closing statement. One of the things that I loved about finding this molten salt nuclear battery, there are no more excuses in the world for people to go hungry or have to drink contaminated water and die, because the molten salt nuclear battery can be used in agriculture, can be used in moving water, in agriculture, even in Alaska, to power environmentally controlled greenhouses using robotics and artificial intelligence. And you can grow all the food that you would ever need in Alaska, not have to import so much. Same way in a place like Hawaii. Hawaii imports 85% of its food, doesn't need to. On any of the islands there's enough room to put a large greenhouse. Using robotics and AI powered by the molten salt nuclear battery for combined heat and power.
I mean, like I said, the future is now. I'd love to see it, and of course, the applications for this are pretty limitless. And I hope you're right. I hope we see this in our lifetimes. I hope we see this come back, because this would solve a lot of those problems. Absolutely, a lot of those problems. Richard McPherson, Micronuclear. Thank you so much for coming on board. I appreciate it.
My pleasure. You have a great day.
Thank you so much.